Okay, so now the important part is we've got to talk about the phase difference. Okay, this is the thing that you use to calculate lots of properties, is phase difference. So I think your book blows through phase really fast, but I think we need to spend time on it because next semester it'll be so important. Next semester will make a lot more sense if we think about this now. You're going to get it in your head, you're going to noodle on it with your subconscious. Let's see, now phase difference. Phase difference, we're going to call it delta phi. So we should always use phi, phi naught, and delta phi. Sometimes we slip up. So if it's a difference, it clearly means between 2 points. Right? Okay, so let's see. What is the phase between 2 points? Let's imagine here we go, that we have an xy coordinate system. You're good at that. All right, y here, x here, origin, whatever. Okay, origin. It does actually matter. And let's say you have a point source here. Point source, what does that mean? Oh, spherical waves, right? When you hear point source, you should think, spherical waves. But my ear is small. Maybe it won't matter. Let's find out. Right? Point source there. And we're going to think about from the point source, which is at a position, x, what's happening at the origin and what's happening at a position p, which is at a height y. We can just call it y. Right? Okay, so source at x comma 0, it's x0, right? So no height, just no y. Point P at y, at 0 comma y. Right? I'm just telling you where these things are located. The origin is at 0 comma 0, as usual. So I think the way I wanted to say it is, what's the phase difference to the origin? Would be an awkward way to say it. Crappy chalk. What is the phase difference from the source to the origin? See what I mean by that? The source is at x0, that's that. Okay? So the way you calculate a phase difference, if you're just dealing with spatial things, is you call that the path difference. So usually you'd write it like delta phi, that's what we call these, and then you can put a subscript to think about what's causing this phase difference. So right now we're just thinking about paths. Right? You could imagine that paths might screw it up, difference in time might screw it up, difference in phi naught, reflections can do things. None of that right now. Let's just think in terms of path. Let's see. So how are we going to get that? Well, it's really a question of how many cycles does it go through? Well, how long? Well, first of all, how far does it go? It goes x. Right? So delta path, it's definitely going to depend on how far it goes. D, we'll call it D to be general. Okay? How far does it go? And then over lambda, how many cycles? And then in terms of radians, everything's in radians, we have to have a 2 pi. Right, that's the number of cycles. Each cycle is 2 pi. So that's awkwardly written. It's supposed to be 2 pi d over lambda. Should have done the 2 pi first. Okay. So in this problem, we would say, well, it's easy. It's just it went from how far did it go d? It's 2 pi. And we would say, how far did it go? X minus 0. It just went x. The wave went that far. X minus 0. Over the wavelength. So that's the phase difference from the source to 0. What about the phase difference from the source to point P, to this place? So that would be from source to, I called it P. So we just look at it again. We say, okay, delta path, delta phi path equals, what's the distance? No, it's not y. It's a square root of x squared plus y squared, right? It's like a triangle. So it'd be 2 times pi times the square root of x squared plus y squared over lambda. Right? So there we've calculated how many cycles it goes through at 2 places. What's the phase difference from the source to the source? 0. Right? What's the phase difference when you go from the source and you move 1 wavelength over? 2 pi, right? You move one wavelength over, that's d is lambda. Lambda over lambda is 2 pi. So the reason these are important is later in the next semester, we're going to think about having two sources come together. Right here I had one source illuminating two places, but you could also have two sources illuminate one place. And then you think about what happens when two waves overlap. And that's why we've got to be good at calculating these phase effects. Okay? For this semester, all we do is say, what does phase mean? Can we get the difference in phase? Okay?